Swayam Prabha. Digital India. Educated India.
So, in the last lecture of this series, let us start with the 1-2 more properties to be very precise: initial value theorem and final value theorem or Z transform. So, initial value theorem says that if Z transform of f n equals f z, then f 0 equals limit z approaches infinity capital F z. So, to prove this one, we will just do it little quickly. F z equals your summation n equals 0 to infinity f n into z to the power minus n. So, if I simply expand the series, this I can write down f 0 plus f 1 by z plus f 2 by z square like this way. So, as z approaches infinity, means limit z approaches infinity f z, all terms will vanish except the first term, that is f 0. So, this completes the proof of the initial value theorem that limit z approaches infinity f z equals f 0. And please note here, from here, if your f 0 equals 0, then we can prove this thing, limit z approaches infinity f z, this will be equals to f of 1. Please note this one, I am not giving the proof of this, that if f 0 equals 0, then limit z approaches infinity z into f z, sorry, limit z approaches infinity z f z will be equals to f 1. Now, let us come to the next theorem, that is final value theorem. If z transform of f n equals f z, in that case limit n approaches infinity f n equals limit z approaches 1 z minus 1 into f z, provided the limits exist. So, let us give the proof of this. We have this thing, z transform of we have this one, z transform of f of n plus 1 minus f n, f of n plus 1 minus f n. This equals, you can write down z transform of f n plus 1 minus z transform of f n. From the linearity property, we can write down this equals z into capital F z minus f of 0. Please note that z transform of f of n plus 1, this equals z into capital F z minus f 0, this we have proved earlier, minus z transform of f n, I can write down capital F z. Equivalently, if you see this, we can write down z transform of f of n plus 1 minus f of n. This is equals to, I can write down z minus 1 into f z minus z into f 0. Just simplifying the earlier term, this equals, you can write down. Now, from here, if I take the summation n equals 0 to infinity f of n plus 1 minus f n into z to the power minus n, that is z transform of f of n plus 1 minus f n. This I am writing using definition as n equals 0 to infinity, the function that is f of n plus 1 minus f n into z to the power minus n. This is equals z minus 1 into f of z minus z into f of 0. So, from here, as limit z approaches 1, summation n equals 0 to infinity f of n plus 1 minus f n into z to the power minus n. This equals limit z approaches 1 z minus 1 into f z minus limit z approaches 1 z into f 0. So, basically we are taking at z approaches 1 on the both side. So, this again I can write it as summation n equals 0 to infinity, after left hand side taking the limit n equals 0 to infinity f of n plus 1 minus f of n. As z approaches 1, z to the power minus n will vanish, and this is equals to limit z approaches 1 z minus 1 into capital F z minus f of 0. Now, if you see what you are getting, summation n equals 0 to infinity f of n plus 1 minus f n. This equals, I can write down, if I z approaches 1 f z, this equals what I can write down, this is nothing but f 1 minus f 0 plus, if I just expand this summation, f 2 minus f 1, then plus f 3 minus f 4, like this way it will continue. Sorry, this will be f 2. So, this will be 3 minus 2, like this way it will continue, and so that ultimately what you will get, all terms will be cancelled. There will be only two terms, one is limit n approaches infinity f of n plus 1, and your f 0 will not be cancelled. So, all terms will be cancelled, here f 1 is cancelling, f 2 is cancelling, like this way, except this f 0 and the last term, that is limit n approaches infinity f n plus 1, all other terms will vanish. So, therefore, the left hand side, that is this one, summation n equals 0 to infinity f of n plus 1 minus f n, this equals, you can write down, limit n approaches infinity, and f n plus 1 then can be replaced by f n minus f 0. So, once I am getting this, if I substitute this value, what I will obtain? On the left hand side, there will be limit n approaches infinity f n minus f 0. This is equals limit z approaches 1 z minus 1 into f z minus f 0. Therefore, what we can say, limit this f 0 will be cancelled, and limit n approaches infinity f n, this is equals limit z approaches 1 z minus 1 into f z, provided the limits, both the limits exist, and this completes the proof. Now, one can ask one question, that why not this value is vanishing, limit why not this value is 0, limit z approaches 0 z minus 1 into f z. Let me give one to counter examples from where it will be clear that depending upon the value of capital F z, this value may not be 0, although you have the term limit z approaches 1 z minus 1 into f z. Say your f z is 1 by z minus 1. In that case, what happens? Limit z approaches 1 z minus 1 into f z, this is equals to 1, this is not 0. Or if you consider f z equals 1 by z minus 1 whole square, then limit z approaches 1 z minus 1 into f z, that is, it will be 1 by z minus 1, that limit does not exist. That is the reason we have told that limit z approaches 1 z minus 1 into f z is this value we have to calculate. So, these are the basic properties of the Z transform, and using these properties, now let us solve some problems quickly, so that you can better understand how to find out the Z transform of various functions using the properties. The first is your Z transform of n cube, we want to find out. We know this thing, already we have done it. Z transform of n is z by z minus 1 whole square. Say this is equals capital F z, and modulus of z is greater than 1. This we have done earlier in the last lecture itself we have done this thing. So, now from here using the property Z transform of n square into n, this equals, I can write down minus z d dz whole square of capital F of z, and so minus z d dz whole square into capital F z. This again we have done earlier using the property I can write down. So, this equals z square d square f z by d z square plus it will be d f z by d z, and already you know what is your capital F z. Capital F z is z by z minus 1 whole square. So, this actually d square d z square of z by z minus 1 whole square, this is one term, and then here it will be, sorry, here one z will come. So, it will be z into d dz of z by z minus 1 whole square. So, simply you have to differentiate for the first case twice, for the second case once, and if you just differentiate it, your ultimate result will be this. Please check this one of your own whether it is correct or not. So, the result will be z transform of n cube is equals to z into z square plus 4 z plus 1 divided by z minus 1 whole square. So, just I am using the property over here, since I know this z transform of n is z by z minus 1 whole square. Using the property I am just by differentiation I am getting the z transform of n cube. Next is, say we want to find out the z transform of f n, where your f n is defined as a to the power n divided by factorial n, where your f n is a to the power n by factorial n. Now, again z transform of 1 by factorial n, this I can write as from definition summation n equals 0 to infinity 1 by factorial n into z to the power minus n. If I expand the series, I will obtain 1 plus 1 by factorial 1 into 1 by z plus 1 by factorial 2 into 1 by z whole square plus 1 by factorial 3 into 1 by z whole cube, and like this way it will continue. And if you see closely this series is nothing but e power 1 by z. If I make the expansion of e power 1 by z, I will obtain this series. This equals capital F z say. Therefore, z transform of 1 by factorial n is nothing but e power 1 by z. So, z transform of a to the power n into 1 by factorial n. Using scaling property, I can say this is nothing but capital F of z by a, and capital F of z is e power 1 by z. So, that capital F of z by a will be equals to e power a by z. So, you see, first I am finding the z transform of 1 by factorial n, and using this particular property that z transform of 1 by factorial n is e power 1 by z. Then using scaling property, we are saying what is the z transform of a to the power n into 1 by factorial n. So, I hope it is clear. Next, let us take another example. It is given that I am just doing the opposite one now. If z transform of f n, this is equals z by z minus a into z minus b, then you find out f 0 and f 1. That, or in other sense, what we want to say is that if z transform of a function is known to us, how to find out the value of f n? Because here we have given the z transform of a function and the inverse one we can find out. Now, you use initial value theorem. Using initial value theorem, what you can write down? F 0 equals limit z approaches infinity f z, and limit z approaches infinity f z is nothing but z by z minus a into z minus b. This equals, if you break it, you will obtain 1 by a minus b into limit z approaches infinity 1 by z minus a minus 1 by z minus b. Therefore, both the limits will be 0. Limit z approaches infinity 1 by z minus a will approach 0. Also limit z approaches infinity 1 by z minus b, this will also approach 0. So, the value is 0. Therefore, is simply using initial value theorem, the value of f 0 is 0. Similarly, I know that f 1 is limit z approaches infinity z f z. Limit z approaches infinity, sorry, this is not small f z, but this is z into capital F z. So, this is equals limit z approaches infinity. If I substitute the value z square by z minus a into z minus b. If I evaluate the limit, simply z square I can both numerator and denominator I can divide, and in that case I will obtain the result as this one, that is f of 1 is 0. F of 1 is 1. Therefore, by initial value theorem, simply I am saying f of 0 is 0, and using this property that f 1 equals limit z approaches infinity f z, and by evaluating the limit we are saying that f 1 this is equals to 1. Let us take some other example, that is inverse z transform of this function z into z plus 1 by z minus 1 whole cube. We have obtained the z transform. Now, we are deriving, we want to derive the inverse z transform also of a function, so that you can do it of your own. You take this function z into z plus 1 divided by z minus 1 whole cube. This equals, you can write down z by z minus 1 whole square into z plus 1 by z minus 1. So, that this I can break it again, z by z minus 1 whole square into z by z minus 1 plus 1 by z minus 1, and this I can write it as f z into g z. So, f z I know, g z I know, this I am assuming, say. So, from here I want to find out what would be z. Now, you know this thing, z transform of n is z by z minus 1 whole square. So, basically your f z is this quantity and your g z is basically this quantity. So, I want to find out the function whose z transform is this. Already we know these things, we have done earlier that z transform of n is z by z minus 1 whole square, and also z transform of h of n plus h of n minus 1, where h is the Heaviside function. So, this equals summation n equals 0 to infinity z to the power minus n plus summation, this will be n equals 1 to infinity z to the power minus n. This we have done depending upon the value of n and n minus 1. So, summation n equals 0 to infinity z to the power minus n, this is nothing but 1 by 1 minus 1 by z. This we have done for the second part. I can write down this thing as summation n equals 0 to infinity z to the power minus n. So, 1 I have added here. So, I have to subtract 1 here. So, this equals, this I can write down z by z minus 1 plus this part again I can write down 1 by 1 minus z minus 1, and this if I simplify, this will be equals to z by z minus 1 plus this will become 1 by z minus 1. So, this term is nothing but this one. So, therefore, I obtained the function whose z transform is this 2. So, what I can write down? Your f n is here. What will be your f n? F n will be n, and what will be your g n? G n will be h n plus h n minus 1. So, let me write down this thing. Your f n is equals to 1 and your g n is equals to h n plus h n minus 1. I hope the method was clear. We are first finding out that function whose z transform is that function of z. From there I am writing f n is this, g n is this. Now, using convolution theorem, I can write down inverse z transform of capital F z into g of z. This is equals to, I can write down summation m equals 0 to infinity, m equals 0 to infinity f m into g of n minus m. This equals summation m equals 0 to infinity m, f m is m and g of n minus m will be h of n minus m plus h of n minus m minus 1 from here. So, I obtain this. So, if I break it, I will obtain two series. One is m equals 0 to infinity m into h of n minus m. Other one will be summation m equals 0 to infinity m into h of n minus m minus 1. So, once I am getting it, so this I can write down m equals 0 to n m, because for other cases from n to infinity it is 0, only 0 to n it is 1. Similarly, here for m equals 0 to n minus 1 it is 1, for other values it is 0. So, m equals 0 to n minus 1 into m. If I evaluate, this is n into n plus 1 by 2 plus this will be n minus 1 into n by 2, and if I simplify this, I will obtain the value as n square. Therefore, according to the problem, your z inverse, this one, your problem was to find out z inverse z into z plus 1 by z minus 1 whole cube. So, this value is n square, that is the value of n square if I take z transform of n square is this. So, I hope it is clear using inverse z transform how to find out the function itself, that is quite clear from here. Let us take some other type of example again. It is given that f n plus 2 into f of n plus 1 minus 3 f n, this is equals 0. This equation is given. Also it is given f 0 equals 1, f 1 equals 0. So, one equation in terms of function of n is given, f of n plus 2 plus twice f of n plus 1 minus 3 f n equals 0, where f 0 equals 1, f 1 equals 0, and we have to find out what is the value of f n. So, just like solving the differential equation, what we have done using Laplace or Fourier transform, here also if one discrete functions equation is given, from there how to find out the value of f n. Now, you take the z transform on both sides of the given equation. So, that you can write down z transform of f of n plus 2 plus twice z transform of f of n plus 1 minus 3 into z transform of f n, this is equals to 0. Now, from the definitions already we know what is the z transform of f of n plus 2, z transform of f of n plus 1, z transform of f n. These things are known to us, we have done it earlier. So, if I simply follow those formulas, I can write down z square into z transform of f n plus 2 is equals to z square into capital F z minus f 0 minus f 1 by z plus 2 into z transform of f of n plus 1 is capital F z minus f 0, and this is 3 into z transform of f n, z transform of f n is capital F z, this is equals 0. So, now you know the values of f 0 and f 1. F 0 and f 1, if I know the values of these two, then I can substitute it and ultimately I can find out what is my f z. My f z will be then z square plus twice z by z square plus twice z minus 3. You please check it up whether it is proper or not. Substitute f 0 equals 1 and f 1 equals 0, and then by simplifying I will obtain f z equals z square plus twice z by z square plus twice z minus 3. So, I will just let me rewrite, that is f z equals z square plus twice z divided by z square plus twice z minus 3. This I can write it as z into z plus 2 divided by z minus 1 into z plus 3, and using componendo dividendo, if you break it up, you will obtain 1 by 4 into z by z plus 3 plus 3 by 4 into 1 by z minus 1, and this on the simplification term 1 by 4 into z minus 3 I can write down plus 3 by 4 into z by z minus 1, 3 by 4 into z by z minus 1. This will be actually z will come here, this will be z by z minus 1. So, f z I am getting this. So, sorry, this is I have written wrongly, this will be capital F z, please note this one, not small f z, capital F z, that is z transform of f n. So, that now from here f n I can write down simply 1 by 4 z inverse of z minus 3 plus 3 by 4 z inverse of z by z minus 1, and we know the values of these things. 1 by 4 into this will be minus 3 whole to the power n plus 3 by 4 into 1 to the power n, and this if you wish you can write down 3 by 4 into 1 minus 3 to the power n minus 1. So, like this way, whenever I am finding, if I have been given a equation in terms of f n and some conditions are provided, in this particular format, by substituting the values of f n plus 1, f n plus 2, I can ultimately write down capital F z equals a function of z, then you substitute it, you take the inverse z transform and find out the value of f n. Let us solve one more problem. We want to find out the z transform of 1 by n plus 1. We know that the z transform of 1 is equals to z by z minus 1. So, this equals say f z. So, therefore, z transform of 1 by n plus 1, that is the division property now. Using the division property, this equals write down z to infinity f x by x square dx. So, please note that here we have used the division property. So, simply what I have to do now, z into z to infinity, you know what is capital F z, that is z by z minus 1. So, x by x minus 1 into 1 by x square into dx. If you evaluate the integral, I am just writing directly z into log of z by z minus 1, because this I can evaluate very easily. So, like this way, whenever as and when required, if you see I have used here division property. So, please note one thing, that whenever I have the problem, I have to find out the z transform of a function or the inverse z transform, whatever properties we have done, using those properties very easily we can find out the z transform. Also, we will provide more assignments on each of them, and I hope that the course will be really useful for you all. Thank you.